This is the video lecture for AP Calc BC, and it is specific to Chapter 4, Objective 5, but it's only going to be the first half. So this will be only integration of composite functions within definite integrals, and then the 5b will be with definite integrals. So before we get started on there, we want to kind of review our chain rule of derivatives. So if we have, ignore that little dash there, I don't know what that's about. So if we want to take the derivative of a composite function, right? So that means we have two operations happening for the variable, right? So that means we'll have to use like power rule twice, or maybe power rule with a trig rule, that sort of thing. So how we take that derivative, we always do the outside rule first, whatever that would happen to be. So we take the derivative of that, and then this guy has to wait its turn, right? So we take that derivative, leave this one alone, and then we go to the inside operation and we take that derivative, right? And then they multiply together. Okay, so we're going to do a couple of those just to kind of review. So if I want to find the derivative of this, so how do I know to use chain rule? Whenever there's that grouping symbol. And that grouping symbol could be radicals, it could be fractions, or it could be all kinds of things that are happening to indicate, hey, chain rule here. But parentheses are typically what we would be expecting to see to know, all right, I got to do chain rule. So if I take a look at this, I first decide, okay, what's my outside, right? And what is my inside? So when I go to take this derivative here, I see that I have this power of 3. So I'm going to have to do power rule for that. And then I'm also going to have to do some power rule in here as well, right? But we cannot do both at once. We have to do one at a time. Okay, so one at a time. So I'm going to start with the outside, so that is power rule. So power rule says we bring the power down in front and reduce by 1, right? This is for derivatives. And then this cannot go yet, so it's going to stay exactly the same, right? So that power, outside power, is done. And then now I move to the inside, so that's this one right here, and I'm going to multiply that by the derivative, right? So when I do that, I'm going to have 6x squared and then minus 4, and then keep that grouped, right? So that is the derivative, okay? And ta-da! So now that one is done. All right, so let's take a look at B. So for this one here, remember what we always want to do on this one is do a little rewrite. So we have this sign squared, but the way our brain needs to think about that is as a quantity squared, right? Whenever we have that trig function. So I'm going to rewrite that as sine of 3x, and then that's quantity squared, right? That's what that squared inside means. So here I have 3, right? 3 pieces I have to take care of. So I have the power rule on the outside I've got to do. I've got the trig function I got to do, and then I've got the angle I have to do, right? So this is going to be a double chain. All right, so we always start with the most outside, so we're going to do power rule, right? And then we'll go and do trig, and then we'll go ahead and do the angle. So power rule, so I'm going to bring down that power of 2 and reduce the power by 1. And I didn't do anything in here yet, right? So just the outside power rule. So then now I'm going to work my way in, okay? So done, right? So now the derivative of sine is positive cosine, right? So done, leave the angle alone. Okay, and then, right, because I can only do one at a time, you got to wait your turn. Now we're going to take the derivative of 3x, the angle. So that would be 3x to the 0, right? 3x to the 0, or just 3. And so there is chain rule. All right, so that's just a review because that's going to help us with, okay, how do I now undo chain rule, right? How do I undo chain rule? So if we take a look at this, so this is chain rule right here, right? So we're using lowercase f to indicate that's a derivative, right? So lowercase f meaning the derivative. And then I have my inside function, and then I have the derivative of the inside here, right? So the derivative of the outside, this is left alone, and then the derivative of the inside. So that has to go back into this format here, right? So we have to like figure out, okay, how do I undo that outside piece? And then how do I like undo, so to speak, that g prime to get back to this, all right? So what that means is, just to kind of make sure, is we are looking for setups like this, right? Setups like this, where we have our main portion first, right? So the main portion first here, meaning that we're only off by essentially a power here, right? So I have a power of 3 and a power of 2. So when I go to find the antiderivative, right, so if I'm given the derivative, I need to figure out how do I go back into that format. So what I first make sure I'm always putting it into this kind of format here to where I have my grouping here first, right? I want my grouping here first, and then I want to make sure the derivative of the inside follows, right? So that if it's in this format, I can work it back into that format, okay? So if I look here, so I would, if I saw this problem, I would do a mental derivative. The derivative, this is 6x squared minus 4, check, right? And so that's the g prime component, and so this right here has to work backwards into that. Okay, so questions that people always ask is, when I'm given this and I ask for the antiderivative and I create it and make it look like this, the question always goes, well, where'd the 6x squared minus 4 go to? Well, it didn't go anywhere. We undid the chain rule piece, right? We undid the derivative of what's inside. Okay, so it didn't go anywhere. We're just like, we know that it goes back into its inside component where we haven't taken the derivative yet, right? So pre-derivative. So pre-derivative, this was not here, right? So pre-derivative, right? Pre-derivative, the chain rule piece was not there. Okay. All right, so we're going to go ahead and do this. So what I'm going to do on this is I'm going to go through and talk about steps and process and all of that. But I also want you to be able to do this mental math as well. So although I'm going to talk about a procedure and here are the steps, I want your brain processing what's going on so that at one point, whether it's in this chapter or in April, the steps kind of leave you and you are able to just boom, there's the integral. Okay, so but we're going to do a process, but I want you to start thinking about how can I do it without a process, right? So like, do you understand it? That's going to be the key thing. All right, so the first thing we're always going to want to do is we're going to want to rewrite it, okay, where our integral is going to be our grouped here first, whatever that is, whether it's square rooting or whatever. So we always want the grouped here, and then multiply by the remaining. So I'm going to put it in here because that'll be, oh, you cannot see anything I'm writing. Sorry, people. Okay, how about that? All right, so I want to rewrite it to where I have my grouped with my power, whatever that might look like. So 1/2 power squared, whatever. And then the remaining terms down here. Okay, so remaining terms right here. And so that is what we always want to do first. Okay, I'm recording, I'm going to be a while. So that's what we always want to do. All right, so that's what our first step is. So here is our grouped component. So we're going to do the 3x squared plus 7, and then that's a power of 3, and then my remaining, my ungrouped term right here is going to be times, and then 6x dx. So hopefully when we do that, like this is our outside function, and then hopefully this is the derivative of that, right? So hopefully this is a derivative of that. So then once I do that, we're going to use what's called a u/du substitution method, okay? So we're going to let u equal the inside of the group symbol. So u is going to equal the inside. And then we are going to compute, meaning we actually have to take the derivative. So then we're going to compute what is the derivative with respect to x of the u. Okay, so we are, like, we don't like look to say, oh, there it is. We actually find that derivative. Okay? All right, so here we go. So that means our u is going to be this piece right here because it's the part with the power. So u is equal to 3x squared plus 7. And then now I want to take the derivative of this with respect to x, right? So the derivative of this with respect to x. Okay, so this will be, so I'm going to do this in pencil because I want to do a little rewrite here. So the derivative of u with respect to x, so that'll be du over dx. And then this derivative will be 6x plus 0, right? And then I want to multiply that dx over to the other side. So I'm going to multiply that dx over to the other side. So that will cancel, right? So I'm going to do that every step. So I will write du over, not rewrite, I will think in my brain du over dx is equal to 6x, and then I'm just going to multiply that dx over every time. So you'll never see me write the du over dx. I'll say it out loud, but then I'm just going to multiply the dx over each time. Okay. So then once I do that, okay, now I'm going to substitute. Okay, so now replace, right? Replace these pieces into my integral. So into my integral. So I'm going to substitute my u and my du terms into my integral. Okay, so that's what I want to look at. Okay, so when I see this, sometimes this might confuse you, but sometimes this might have to modify, right? You might have to tweak it a bit. And when you adjust it, it'll be to multiply or divide something out. Okay, so the way you might be processing this might be a little difficult, but what I want you to do is I want you to think about the fact that 3x squared plus 7 is equal to u, right? 3x squared plus 7 is equal to u. And then 6x dx is equal to du, right? So like however, like these are equal statements, I'm just rewriting it to make sure that we're seeing that. Okay, so now let's go ahead and do that substitution. So when I'm looking at this, so I have to do a substitution. So what am I going to replace 3x squared plus 7 with, right? So I look up here and all my x terms need to turn into terms of u. So I have a 3x squared plus 7, so that would be u. And then the power of 3 is still there. And then 6x dx is equal to du. So all of that will be equal to 1 du or du. Okay. And then now when we're done, now we should have some sort of rule, right, that we know how to integrate. Okay, so now we're going to go ahead and integrate. And again, the only two rules essentially that we have is the power rule and then our trig rules. And I know in trig rules are 6, but we have power rule and trig rules, that's all we have, right? Power rule, trig rules, that's all we have. So when I look at this, will this fit into a power rule or a trig rule category? And it will fit into a power rule category. So when I integrate this, I'm going to add 1 to the power. So that would be add 1 to the power and then divide by the new power. And then, of course, plus constant because we are in an indefinite integral. And so our answer, our question was in terms of x. So we have to go back into terms of x's as well. So I'm going to do a last substitution, 1/4. And u was 3x squared plus 7. So I'm going to substitute that out to a power of 4 and then plus my constant. So if I want to check it, right, if I want to check it, I would take the derivative. So this derivative, I would bring down the power of 4, which would cancel, right? And then I would get 3x squared plus 7 cubed, which is what I have here. And then times the derivative of what's inside, which is 6x, which is what I have here. Okay? All right. Good? Okay, let's do another one. All right, so let's take a look at question B. So again, first thing I want to do is I want to rewrite this in a grouped fashion, right? So I want to rewrite it. So my grouping is going to be that radical, but I want to make it to a power of 1/2, right? So a power of 1/2. Scoop this down a little bit. And so then now my remaining terms, which is 4x, goes to the end. Okay. So then when I look at this, I know that my u should be what is inside the grouped term with the power, so that would be 2x squared minus 1. And then I want to take the derivative with respect to x. So this would be du over dx right now, but what am I going to do with that dx? I'm going to multiply it over. So this derivative, so I'm going to take this derivative, so that would be 4x to the power of 1, and then that derivative is 0. So there's that. And then now I want to do a substitution, right? So now let's go ahead and do that substitution. So I look up here, I have to replace 2x squared minus 1 with something down here, right? So here's that 2x squared minus 1, and it's equal to u. So that will be u to the power of 1/2. And then now I have to look over here, right? So what am I going to replace 4x dx with? So I look over here, what can I replace it with? And I can replace it with du. And then now I only have two things to think about. Do I have power rule or a trig rule, right? So what do I have here? So I have power rule or a trig rule, and I have power rule. So power rule means we add 1 to the power, So 1/2 plus 1 is 3/2. And then I divide by the new power, and then plus c. And I'm integrating with respect to u, and I only have u's here. Okay? All right, so then let's go ahead and fix this. So dividing by a fraction is the same as multiplying by the reciprocal. And then u, right, so replace u, so go back to being in terms of x. So u is the same as 2x squared minus 1, so swap that bad boy out, or good girl, whatever we want to say. And then that would give me plus c. And again, if I took this derivative, hopefully I get back to that, right? So if I multiply these together, that is equal to 1. And then I would have 2x squared minus 1, and that would be a 1/2 power, which is square root. And then times the derivative of what's inside, which is 4x. So then if I took this derivative, I would get that. So this is the antiderivative of that. Okay. All right, let's do another one here. So here's c. Okay, so again, how do I know I should be using u to u or chain rule? Because I have a grouping, right? Anytime I have a grouping, that is when I should be using chain rule. So there is no rearranging going on here, right? Because this is the trig function operation on that angle. So there's no rearranging necessary. But I still need to do u to u. So I would let u equal the grouped piece, right? So that would be a 4x. And then now I have to calculate the derivative of this, right? So I have to calculate the derivative of this. So this would be du over dx, right? But I'm always going to multiply that dx over. And then I have the derivative of 4x would be 4x to the 0, or just 4. And then again, I'm multiplying that dx over. Okay. All right, so now I need to do a substitution. So let's go ahead and do that. So sine is an operator, so that doesn't substitute. So that will still be a sine. And then the 4x will replace with u. And then I need to replace the dx. So the replacement of dx, so right here, so somehow I have to figure out what does dx equal. Well, the issue is I got a 4 here and I don't have a 4 there, but I still have to replace dx because I need the u and the du down here. So then I can do a little bit of arithmetic. So I'm going to divide by 4, so divide by 4. And so then when I do that, so I will have dx is equal to du divided by 4, or 1/4 du, right? So now I have a replacement for the dx, and that is 1/4 du. And then 1/4 is just a coefficient, right, or a scalar, right, just a multiplier. So I'm going to move that guy to the front here so it doesn't distract me from what I'm trying to do. So then I have sine of u du. And so right here, I know I have only two possibilities, right? It is either power rule or it's a trig rule, right? That's the only two things I know right now, power rule, trig rule. So do I have an antiderivative for sine of u that I know? And I do, right? And that would be, is that cosine or is it negative cosine? I'm going to let you guys think about that before I say. So should that be cosine or negative cosine? And it should be negative, okay? All right, I'm not done though, right? Because this is in terms of u, and I always need to go back in terms of x. So then this would be cosine, and then my substitution for u is 4x, so that will go back as a 4x, and then plus c. Okay? All right, so we have a few more because I know this can be tricky. All right, so here is d. And if you feel like, oh yeah, no, I totally got it, okay, then excellent, right? Excellent. Okay. So then hit pause and try to do number 5 on your own, right? If you think you're like, got it in the bag. All right. So right here, when I look at this one, all right, so I have secant squared 1/2 x. So my brain, I should be thinking like, oh, I've got this grouping here, but squared also means I have a grouping as well. So, but do I know the antiderivative of secant squared of anything? And I do, right? That is tangent. So then my grouping is going to be that 1/2 x. So then I'm going to let u equal 1/2 x. And that derivative is going to be 1/2 dx, right? So du over dx, or 1/2 dx, okay? All right, so that's what I'm thinking. And the 5 right here can just run to the front because it's just a scalar. So I have 5, and then I have secant squared. Replace the 1/2 x. So if I look down here, 1/2 x can be replaced with u. And then dx, I don't have a replacement yet, right? So that dx I need to fix. So in order for me to have a substitution, I'm going to multiply both sides by 2. So when I do that, so just right here, I will have 2 du is equal to dx. So the dx will have a substitution of 2 du. And then I'm going to pull that 5 and 2 together, so pull that 2 out, so that will give me a 10. And then now I have to decide, okay, is this a power rule or is it one of the trig rules I know? So is it power rule or one of the trig rules? So if I run through the trig rule list, this is one I know, right? And the integral of secant squared is tangent. Okay, and again, not done though, right? Because I can't leave it in terms of u. I have to go back in terms of x. So then that would be 10, and then tangent of 1/2 x, and then plus c. Okay? All right, so rolling along here, rolling along. Okay, let's take a look at E. So we're going to do another one. So here I have a product of two things, right? So I don't have a product rule, right? There's no product rule for integration. So I know that I can't leave it like this because I also know that if I run through the trig list, this is not an integral I know, right? Yes, I know the integral of sine. Yes, I know the integral of cosine. Yes, I have a power. But I don't have, like, in the list of 6, I don't have anything that looks like that, right? And so I don't have a product rule for integration, so I cannot, like, make one up. So what I can't do is say, well, the integral of sine is negative cosine. This would be cosine to the 4th divided by 4. Like, that's just making stuff up, okay? Because this is not in a power rule format. Remember, that's like a x to the n plus b x to the n. This is not a list of the 6 that I have, so I can't just like make something up and just do them separately, right? So I'm going to do my rearranging since I don't know any of that. So my rearranging is the grouped first, so that will be this right here, and I'm going to write it as a grouping, cosine of x quantity cubed. And then my remaining term, which is sine x, afterwards, okay? So that would be what my grouping is. So if you're like, oh, I think I got it, then you try the UDU and then forward and see if you did get it. All right, so we're going to let u equal the inside, so that would be cosine of x, and then now I'm going to take that derivative. So the derivative of cosine is negative sine of x dx. Okay, and so now let's do our substitution. So then cosine of x, so I'm looking down here, what can I replace cosine with? I can replace it with u, and then it will keep that power of 3. And then now I need a replacement for the remaining terms, so that would be sine of x and dx. So if I look down here, I have close to a sine of x dx. So I'm just going to divide that -1 over to the other side, so then that means I would have negative du is equal to sine of x dx, right? And so then now sine of x dx will replace with negative du. And then that negative is just a scalar, so I can move it to the front to make that a coefficient. And then once I get to here, I have to decide, is that something in the format of power rule or a trig rule? And so this would just be power rule, so I have that negative. So I'm going to add 1 to the power and divide by the new power, and don't forget your constant. And then again, we have to be in terms of x, not u. So I'm going to go ahead and look to see what u should be replaced with, and it should be replaced with cosine of x. So then this is really just negative 1/4, right? So negative 1/4 and then cosine of x to the power of 4 plus c. Okay? All right, we're going to do 2 more here, 2 more. But if you're feeling like, oh, I totally got this, and you're like rocking and rolling with it, then you know, just try to do the 2 here that you see on your own, and then just look to see if your answer aligns with mine. Okay? Oh, somehow this integral went away, so let me fix that. Okay, so let's do a little rearranging here. So this is the grouped with the power. So even though this is grouped, this is the part with the power, right? So this should go first. So I'm going to do go ahead and do a little rearranging. And then follow up with the 2x minus 1, right? And again, we're just making sure that we have that in the right order. Okay, so then now this will be my UDU, so I'm going to let u equal the inside of the grouping part with the power, so that would be 2x squared minus 2x plus 5. And then now I take the derivative of this with respect to x, but I'm going to multiply that dx over. So that would give me 4x minus 2, and then multiply the dx over. Okay? All right, so now we go and do our substitution. So let's just start with this variable component first, and I look down here to see what that could be replaced with. So that could be replaced with u, and then it still has a power of 4. And then I look at this to see what can that be replaced with. And so if I look down here, I don't have it matching exactly right, but is there a way I can adjust this so it aligns with that, right? And so if I look at this, so if I look here, I could adjust it pretty close if I divide by 2, right? So if I divide by 2, so then that would give me 1/2 du, and then that would be 2x, and then negative 2 divided by 2 is negative 1. And so then always my remaining terms, keep them together, so my remaining terms can be replaced with 1/2 du. And then I'm going to go ahead and move that 1/2 to the front because it is just a number value and there is no variable attached to it, right? I cannot move a variable to the front, just numbers. All right, so then now I look to see I can do power rule. So I'm going to add 1 to the power and divide by the new power, and then plus a constant. So that would give me 1/10, and then now remember we have to go back into terms of x, so what can I replace u with? So I can look up here and I can see I can replace it with that trinomial. And then that would give me that equation. Okay? All right, last one here, last one. Okay, so let's take a look at this one. This is our last one. So again, we want to do a rearrange, right? Rearrange. So this is the piece that's grouped, right? Because that's the radical. Okay, so that means I'm going to move this up to the front, right? So it needs to move up to the front. And so that will be x cubed minus 3x squared. And then this is a cube root, so that would be a 1/3 power, but we're moving it up, so that would be a negative 1/3 power. And then my remaining term is that numerator. And then with respect to x. Okay. All right, so then my u is going to be what's inside the grouping, and now even though this is grouped, it's just a power of 1, so we want to use this one right here because it's the power of negative 1/3. So I'm going to let u equal x cubed minus 3x squared, and then I'm going to take that derivative with respect to x, right? So with respect to x, so that would be 3x squared, and then minus 6x, and then bada bing, bada boom, multiply the dx over. Okay, so rocking and rolling, right? Okay, so now let's go ahead and do our substitution. So we just go left to right. So I have the integral. I look to see down here, what can I replace x cubed minus 3x squared with? And I can replace it with u. And then that would be to a negative 1/3 power. And then now I check out my remaining terms. What can I replace my remaining terms with? Almost that, right? Not quite, but pretty close. So how will I make that work? I will make that work by dividing by 3. And I've crowded myself into a corner, so I'm going to do a little shaving up here. Let's do it up here. Okay, so then I will have a 1/3 du, and then when I divide by 3, I'll get x squared, and then negative 6 divided by 3 is negative 2x, and then I have my dx, right? Okay, so then now what are my remaining terms going to be replaced with? With 1/3 du. But I know I'm going to pull that 1/3 out to the front anyway, so I'm just going to go ahead and just do that right now. So that 1/3 I just moved to the front. And then now I'm going to do power rule. And so I'm going to add 1 to the power, so that would be 2/3. And then dividing by 2/3 is the same as multiplying by the reciprocal, right? So instead of dividing by 2/3, I just multiply by the reciprocal. And then this will give me 3/6, which is 1/2, and then replace the u. And ta-da. So hopefully now we are masters of chain rule or u to u substitution, and then we are going to start working on kind of that mental math component as well. But there you go.